Hello everyone, thanks for watching Edupedia World videos. In the previous few videos we completed straight lines and planes and direction cosines, which was basically an introduction to 3D geometry. In this video I'd like to do 4 or 5 important advanced problems which will tie all of these concepts together and help you do the problems faster. Okay, so first let's start with a question about planes, which I'd like to solve two different ways to show you one rigorous way and one quicker way. So the question is, find the equation of a plane that contains the point 1, minus 1, 2 and is perpendicular to two given planes. The first is 2x plus 3y minus 2z is equal to 5, and the other is x plus 2y minus 3z is equal to 8. So the first is the rigorous way. We know that it passes through this point, so all we need is the perpendicular direction. Now we are given two planes. The third plane is perpendicular to this, so the third plane should be parallel to their perpendicular directions, which means the perpendicular direction to the third plane, so listen to this statement clearly, the perpendicular direction to the third plane will be perpendicular to the perpendicular directions of these two planes. Let's say you have two planes like this and you have their perpendiculars. If you want a third plane which is perpendicular to both these planes, then the perpendicular to that third plane will be perpendicular to both these lines. Right. So that's the concept we'll use. That's the more general concept. So for the first one, we know what direction it is in. Now I'll not bother with the unit vectors. I'll just write the vector n. So the first case, it will be 2i plus 3j minus 2k, and these are the directional ratios, not the direction cosines. I'll just say this is n1. What is n2? That is I plus 2j minus 3k. So what is the third perpendicular direction which is perpendicular to both of them? And we just need one. So what we can do is we can take their cross product and we'll get n3. So what will that come out to be? I cross I is 0. Just for the sake of reference, I always like to draw this whenever doing cross product. I cross j is k, so we have 4k. I cross k is minus j, so we have plus 6j. J cross I is minus k, so we have minus 3k. J cross j is 0, j cross k is I, so we have minus 9i. K cross I is j, so minus 2j. K cross j is minus I, so plus 4i, and then 0. So this comes out to be minus 5i plus 4j plus k. So this is the third one. And now we can find the unit vector n3 cap. That will be minus 5i plus 4j plus k divided by root of, so we have 25 and 16 and 1. So 25 and 16 gives me 41 and 1 42. So root 42. Yeah. Now we have a plane which passes through this point and contains this line. So we know how to calculate the formula of a plane. We can simply use the formula. Actually, I didn't even need to find out the magnitude or get n3 cap. R minus a dot n cap, or n vector also, is equal to 0. This is the standard formula we studied in the video for planes. This is the formula for a plane which is passing through a point with position vector a and is perpendicular to this vector. So what will this come out to be? R is xi plus yj plus zk, and this is 1 minus 1 2. So x minus 1 I plus y plus 1 j plus z minus 2 k dot product with minus 5i plus 4j plus k is equal to 0. So the final answer we get is minus 5 into this. So that will be minus 5 times x minus 1. So minus 5x plus 5, then plus 4y plus 4 plus z minus 2 is 0, so that tells me 5x minus 4y minus z, and then you have 5 and 4 is 9 minus 2 is 7, so you have plus 7, so 5x goes to the side, 7 is equal to 7. So this is the desired equation of the plane, 5x minus 4y minus z is equal to 7. But now we didn't have to do all of this. We could actually have done it by a much shorter method, especially in a paper like IIT JEE where you might have objective questions. So I'll now tell you the shorter way to do this. By the way, you should always know the longer way, more importantly, because even if you don't know the shorter way, it might take you a little bit more time, but you'll be able to do it. So knowing the longer way as opposed to the shorter way is better than the other way around, but ideally you should like to know both ways. So any plane we know can be written as ax plus by plus cz plus d is equal to 0. It's as simple as that. So what we'll do is, first of all, this plane has to satisfy this equation. And obviously these are not 4 variables, there are actually only 3 variables because we just need the ratios. So the first equation is a minus b plus 2c plus d is equal to 0. What is the second equation? Now we can use the fact that when two planes are perpendicular, we've studied this before, let's say a1x plus b1y plus c1z plus d1 and a2x plus b2y plus c2z plus d2 were perpendicular to each other. Then what we have is a1a2 plus b1b2 plus c1c2 is equal to 0. That is the condition we have. So we'll use that. So making this plane perpendicular to this plane gives me 2a plus 3b minus 2c is equal to 0, and making it perpendicular to this one gives me a plus 2b minus 3c is equal to 0. Now using these equations, you will not be able to calculate a, b, c and d explicitly obviously, but you'll get something like c is equal to minus 5a or something like that. Oh sorry, minus a by 5, because a is minus 5, and that will give you c is equal to 1. So something like that you'll get. I'll not solve it, I'll not spend time on that, but once you have these, you can actually get values of a, b, c and d. Or even better, if you have an objective choice question with 4 options, you can just put in the 4 options and see which one of them satisfy these 2 values, right? So this is what is really good about planes as opposed to lines. Lines have a lot of parameters. For planes you have 3 basic parameters, or in this case 4 with the ratios, and you can just assume this to be the equation of a plane and just put in the values. Now we'll try to do a problem which encompasses concepts of both straight lines and planes, as we did those in different videos. So the question is, we need to find the coordinates of a point where the line through the point, so L1 is a line through 2 points, and we know the moment we know 2 points, we know the equation of the line. It is uniquely determined. So it is through 3, 4, 1 and 5, 1, 6. So this is a line, and then we need to find out the coordinates of the point where this line crosses the xy plane. So we need the intersection of a line and a plane. The plane in this case is actually quite simple. The xy plane has the equation z is equal to 0. If you were to look at it in terms of ax plus by plus cz plus d is equal to 0, it is basically an equation where a, b and d are all 0 and c is equal to 1, which gives me z is equal to 0, which is the xy plane. So first what we'll do is we'll simply calculate the line through these 2 points. We already know how to do that. If we call this point A and this point B having position vectors A and B, then basic equation for the line is equal to R is equal to A plus lambda B, where B is the direction of the line. But here the direction of the line will be B minus A. Right, and you could obviously have A plus lambda times B minus A as well, but this will be the equation of the line with the parameter being lambda. So the equation of the line basically is 3i plus 4j plus k plus lambda times the difference. So 5 minus 3 is 2i, 1 minus 4 is minus 3j plus 5k. So this is basically R, which is xi plus yj plus zk. So from that we can see we'll just simplify the LHS. That is 3 plus 2 lambda times I plus 4 minus 3 lambda times j plus 1 plus 5 lambda times k, and this is equal to xi plus yj plus zk. So we'll just write equal to lambda everywhere. So x is equal to 3 plus 2 lambda, means x minus 3 divided by 2 is equal to lambda. Similarly, 4 minus 3 lambda is y, so which means 3 lambda is equal to 4 minus y, or negative of y minus 3 lambda is equal to y minus 4. So y minus 4 by minus 3, and this is also equal to z minus 1 by 5 equal to lambda. So this is the equation of the line, right? The equation is still valid in this form as well, but this is the general form in which we try to write it. And from this we can just intersect it with the xy plane, which tells me z is equal to 0, right? So z we know is equal to 1 plus 5 lambda, which is equal to 0. What that tells me is lambda is equal to minus 1 by 5. And once we know that lambda is equal to minus 1 by 5, we can quickly and very easily calculate x and y, which will give me the actual coordinates of the point where they intersect, and that can be calculated quite easily. X is 3 plus 2 lambda, so 3 minus 2 by 5, which is 15 minus 2, 13 by 5. And similarly, y is 4 minus 3 lambda, or 4 plus 3 by 5, or 23 by 5. So the point is 13 by 5, 23 by 5, 0. In the next question, we are given two lines and we need to prove that they are coplanar, or alternatively find whether or not they are coplanar. So the lines given to us are x minus a plus d by alpha minus d is equal to y minus a by alpha is equal to z minus a minus d by alpha plus, this is delta, sorry, this is not d. Delta. This is the first equation. We can just take this equal to k, and then the other equation is x minus b plus c by beta minus gamma is equal to y minus b by beta is equal to z minus b minus c by beta plus gamma. Let's say this is equal to L. Now we know the formula for when two lines are coplanar. If you have two lines such as x minus x1 by a equals y minus y1 by b equals z minus z1 by c, these are all 1. And similarly, x minus x2 by a2 equals y minus y2 by b2 is equal to z minus z2 by c2. Then these two lines are coplanar if this particular determinant is 0. x1 minus x2, y1 minus y2, z1 minus z2, a1 b1 c1, a2 b2 c2. If this determinant is 0, then these lines are coplanar. We've already proved that in one of the previous videos, right? So we can just do this here. The only important thing is take care of the signs. So for example, when you have x minus a plus d, that is actually the same as x minus a minus d, right? So the first term x1 will not be a plus d, it will be x minus d. So that's the sort of thing you need to remember. Now I'll just write the determinant properly. First we'll have x1 minus x2. This is a minus d, this is again b minus c. So what we'll have is a minus d minus b minus c. Similarly, y1 minus y2. y1 is a, y2 is b. So a minus b. z1 minus z2. This is a plus d. So z1 is a plus d. So a plus d minus b plus c. And then you have alpha minus delta, alpha, alpha plus delta, beta minus gamma, beta, beta plus gamma. And what you can do is you can clearly see from this determinant structure what you need to do. You can subtract the first column from the third column and the second column from the first column from the second column and the third column from the second column, and what you'll be left with is so this can basically be written as A minus B, and then you have plus C minus D, and subtract from A minus B, all you have left is C minus D. Actually, we'll go the other way around, so we'll do D minus C. That'll stop some minuses, and then here you'll have delta, here you'll have gamma. Similarly, in this point you subtract the second from the first, you have D minus C again, delta, gamma, and whatever you have in the middle, A minus B, alpha, beta. Now you can see this and this row is completely identical, the column, the first and third columns are completely identical, which obviously means this determinant is 0, and hence we've been able to prove that these two lines given to us belong in the same plane, they are coplanar. Let's look at one final question. This is sort of an advanced question, so we'll look at it in a little bit detail. A line makes angles alpha, beta, gamma and delta with the diagonals of a cube. We need to find the value of cos square alpha plus cos square beta plus cos squared gamma plus cos squared delta. Now we know there are 4 diagonals in a cube, so obviously the line will make a particular angle with each and every one of the diagonals. We'll just take the direction of the line to be the vector b, the consistent notation. Now we need the vector for the diagonals. We'll try to choose our simplest possible cube, a cube which has a side of length a and one side at the origin. I apologize for my drawing. So if this is the origin, then this side would be a comma 0 comma 0. This would be 0 comma a comma 0, and this would be 0 comma 0 comma a. This point would be a comma a comma a. This point would be x is 0, 0 comma a, and so on. You'll be able to write all of them. But this point we've taken to be 0 comma 0 comma 0, which has simplified a lot of things. So the first diagonal will be between the origin and the point opposite to that. Let's call it D1. So that will have the direction cosines, or the direction ratios rather, A, and A. It will basically be A I cap plus A j cap plus A k cap. This is the first diagonal. What is the second diagonal? We'll take, let's say, this point and this point. So this point is a comma 0 comma 0. This is 0 comma a. So the direction cosine will be minus a I cap plus a j cap plus a k cap. By the way, this is something you may have done before, the diagonals of a cube. So one is all positive, the other 3 are 1 negative each. Similarly, if you are having confusion with this, you can just try to make a cube and then try to solve it properly at your home, at your leisure. So D3 will be AI minus AJ plus AK, and D4 will be AI plus AJ minus AK. So now we can just calculate the angles. Let's say B has the direction cosines LMN. So it is Li plus Mj plus Nk, where L square plus M square plus N square is 1. So this is not the B vector, this is the B unit vector. So what is cos alpha? Cos of the angle between this line and D1. So D1 dot this divided by mod this mod D1. So what we'll have is AL plus AM plus AN divided by mod of B, which is 1, mod of D. Mod of D will be square root of A square plus A square plus A square. So square root of 3A squared, or root 3A. A and A cancel, and what I'm left with is L plus M plus N by root 3. Similarly, the others, cos beta is minus L plus M plus N by root 3, cos gamma is L minus m plus n by root 3, and cos delta is equal to L plus m minus n by root 3. And what we need is the square of these added up. So I'll just rub the upper part. This 4 diagonals, if you're having a little bit of trouble understanding, I suggest you actually take a piece of paper and make a cube, and you'll be able to get it. So cos square alpha is basically L plus m plus n whole squared by 3. So that is L squared plus m squared plus n squared plus 2lm plus 2ln plus 2mn by 3. This is the first one. Then cos squared beta, that will be L squared plus m squared plus n squared, but you have minus L. So minus 2lm minus 2ln plus 2mn by 3. And then you'll have two other terms like this, something by 3, something by 3. And when you write it, what you'll see is 2lm cancels with minus 2lm, 2ln cancels with minus 2lm, 2mn and 2mn will cancel with something here, and all these terms will cancel, and all you'll be left with is L squared plus m squared plus L squared, L squared plus m squared plus n squared, same here, same here. So what you are left with is 4 by 3 times L squared plus m squared plus n squared. But we already know this is equal to 1 because L, M, N were the direction cosines, and the direction cosines always have this property. So the answer comes out to be 4 by 3. Cos square alpha plus cos square beta plus cos square gamma is equal to 4 by 3. So I hope these problems have helped give you a little bit of practice in how to apply the formulas which you've learned so far. And as usual in maths, the more you practice, the better you'll be able to understand it, and the quicker you'll be able to solve problems. Thank you.